particle physics I find really interesting because you're really asking the kind of most fundamental questions, right? You're really trying to get to the bottom of why everything is the way it is. And the LHC, I think, is the most exciting experiment in particle physics at the moment. It's got the kind of biggest opportunity to maybe answer some of the really big questions out there.
So personally, I really enjoy working on an experiment like the LHC, because really what we're doing is trying to understand the real fundamentals of how the universe works. We're really getting down to the basics here. And I kind of find that really inspiring to be, on your day-to-day job, although of course you get bogged down in the details. When you actually step back and think about it, what we're really trying to do is understand how our universe works, which I just find pretty mind-blowing. So the LHC, the Large Hadron Collider, is a huge particle accelerator, which is in Switzerland and France. It collides together subatomic particles known as protons, close to the speed of light, and they collide together at certain points around the ring, and those points around the ring are surrounded by huge particle detectors, and when they collide together they smash up and make a load of new particles, and it's those new particles that we're detecting.
We have a theory of how fundamental particles work, how they interact with each other, what are the fundamental things that everything else is made of. And in order to make that work, we need to postulate this field that fills the universe, and it's by interacting with that field, this quantum field, that particles get mass, which is a lovely theory, but then you ask, well, what's the evidence for that theory? Well, the evidence is, if that field is there, you can make a wave in that field, and that shows up as a new particle, and that's the Higgs boson. So it's the evidence that there's this field filling the universe, giving fundamental particles mass.
So one of the real challenges in trying to discover the Higgs at the LHC is that it's a very, very rare process. And in fact, only 1 in every about 10 billion of the proton-proton interactions that occur would produce a Higgs boson. So really the challenge is trying to find this needle that is a Higgs in the haystack of these other processes that are occurring.
The Large Hadron Collider is about a lot more than just the Higgs. At the energy where the Higgs is, in fact, because the Higgs is there, 2 of the forces, fundamental forces in nature, are actually unified as well. And this is a fundamentally, qualitatively different region of physics that we've never really had access to before. So we're really on the shoreline of exploring this new territory at the moment. Now, of course, we want to measure this new boson, the Higgs, see if it really is the standard model Higgs, and do all that. But there's plenty of other stuff might be out there. I mean, either our theory will be shown to work for the first time in this completely new landscape of physics, or we'll find something unexpected and new up there. But it's either way, you don't turn it off when you've only just landed on the shore.